All right, we are going to look at the free response section of the Math 7 exam here. Okay, so as you and your mom started a road trip, you noticed the low fuel light is on to tell you that the car is almost out of gas. Your mother keeps a record of how many gallons of gas are in the car and how many miles she can drive with that amount of gas. So here we've got the record. The first thing is to find the constant of proportionality and to explain what it represents in the context of this situation. So not just a number, but like what does it mean in terms of the gallons of gas and the miles you have driven. Okay, so if you are struggling to remember a constant of proportionality, you can pull out that star chart and you see, oh hey, constant of proportionality, there is my formula. Okay, so k equals y over x. What's the constant of proportionality? Ew, but these are g and m. Huh. Okay, so y we know is our dependent variable. And x is our independent. So which one of these is independent and which one is dependent? We want the thing that happens no matter what, and then the thing that kind of, it depends. So do you have different amounts of gas based on how many miles you drive? Or can you drive different amounts of miles based on the gas that you have? Now you could kind of phrase it in a, if you have this many gallons, you can only drive this many miles, or if you drive this many miles, you use up this many gallons. But that way doesn't always work out because you can't drive more miles than you have gas for. So the number of miles you can drive is limited by the number of gallons that you have, which makes this our independent variable and miles our dependent variable. So we're going to look at this as kind of like our y, our dependent variable, and this would be our independent one. Okay, so let's put, dividing by 10. I think that's nice. 280 divided by 10 is going to be divided by 10, 28. So there's our number, but that's not our only answer. We need context and we need units. So 28 what? 28 miles for every gallon. That sounds about right. Okay, so we would say for every gallon of gas, your mom can drive 28 miles. So that's constant. It doesn't matter if you're driving 1 mile and you'd use up a portion of a gallon of gas. If you're driving 28 miles, you use up 1 gallon. If you're driving 56 miles, you're using 2. It's a constant, which is in the name. Okay, so this right here would be our final answer. And let's see, if I can pull up the scoring rubric, I'll show you how many points it's worth. Okay, awkward. The scoring rubric is from 2 years ago, and it apparently did not save. So, moving back to our thing, if I were creating this question for this year's common assessment, would make it worth 2 points, one for the 28 and one for the context that you provided about gallons of gas and driving and things like that. So that would be 2 points. Okay, write an equation that models the relationship between miles driven, m, they're defining our variables, and the number of gallons of gas, g. Okay, an equation I know has to have an equals sign. It's not an expression. So we said that our miles driven is our dependent variable. That means we're going to say m equals, and what do we have to do? Our constant is 28. 28 miles for every gallon of gas that we have. There's no, it's not a y equals mx plus b form. There's no anything that got added on or subtracted off. It's just a constant proportional relationship, so that is our equation right there. That would be worth 1 point. You could have also written it as 28g equals m. We would accept that. What we would not accept is g28, because that's not the form that we write coefficients and variables in. When you're writing a multiplication problem with a variable and a number, it's the way I think of it is it's math class. Numbers are more important than letters. So our number, our numeric coefficient, or our constant k there, our constant of proportionality, is always going to come before our variable. Okay, next one, C. The low fuel light tells your mom that she has half a gallon of gas in the car. The nearest gas station is 26 miles away. Will you and your mom have enough gas to make it to the gas station? Justify your answer using complete sentences. So justify means like prove it. So this one you will not get credit if you just put like yes or no. You need to actually prove it with math and complete sentences. Okay, so 26 miles away, you can drive 28 miles on 1 gallon of gas. So half a gallon of gas, you can drive half of 28, which is 14 miles. Ooh, you and mom are going to have an adventure because you do not have enough gas to get you to that gas station. That's why you always want to make sure you fill up your tank and you don't leave it till the light comes on, because you can drive 14 more miles. You're not going to make it to the 26 miles away. So my answer would say something like no. We can't make it, or we cannot make it 26 miles because this part not getting me that justify point. I need the because and the why. We can only drive up to 14 miles on half a tank of gas. You could leave it there. That's fine. That would be an excellent and complete answer. Probably like a, if I were just to grade this on a scale of 1 to 5, I'd say like this is a 4. To make it a 5, I would say no, we cannot make it 26 miles because we can only drive 14 miles on half a tank of gas. And 14 is less than the 26 miles we needed to get, oh, I'm running out of room, to the gas station. Okay, so I added a comparison. That's great. I also really like that this is like the extra context. I really know that you understand what's going on in this problem. If you're adding in all this context about like where are you trying to go? How far away is it? Why do you need to get there? Oh, this is how long you can actually travel, and it's not enough, and I can prove it with a math comparison. This would be like the woo! You really know what's going on. Super awesome answer. You don't need to point exactly directly, like no arrows to your math over here, but it really helps when we're grading if we can see the math that you did to come to this answer, because then I'm not questioning, did you somehow look at your neighbor's page and see that they wrote no? Like, I can see that you understand the math and you can turn it into the context. This would probably also be worth 2 points, 1 for the no and 1 for the good justification. Although, quite honestly, in 7th grade, we're trying to wean you off this being 2 points. So if we're holding you to high standards, which we want to, I might actually honestly say this is worth 1 point. And then going back up here, if we're holding to high standards, maybe this is only worth 1 point. Or maybe this one's worth 1 point, and this one's worth 2 points for the no and the justification. All in all, I would say this page is probably worth 5 total points. All right, next up. Using the equation you wrote in part B, oh, don't put that page away. In part B, I wrote this. M equals 28G. Okay. Determine how far your mother can travel on 18 gallons of gas. Okay, how many miles can we travel if we can do 28 miles to each gallon and we have 18 gallons? Okie dokie. 8 times 8 is 64. 8 times 1 is 8, plus 6 is 14. Placeholder. 8 times 2 is 8 and 8 is 16. 2, 3, add 4, 10, 5. 504. It doesn't say it here. When I write exam questions, it will say it, but you have to include your units. I'm super picky about units. 504, what? 504 armadillos? 504 gummy bears that you ate? No, Mom can travel 504 miles. Great, you got the point. Even better, what would really make me feel super confident in seeing your answer is something like this. If we have 18 gallons of gas, we can drive 504 miles. That's really good, and I'd be like, woo, yes, nice job. Even more amazing if you really want to push it, going 28 miles per gallon. That tells me that you can even bring in the context. You understand really what that 28 means. It means every gallon is 28 miles. This would be like, oh my gosh, amazing. I'm so proud. There are times when we're grading the common assessment where teachers will walk into the other room and be like, who teaches this student? And someone will be like, me? Like, they did such an awesome job answering this question. Oh my gosh, I'm so impressed. Like, that's what you're going for. You want everyone to be like, not only do they know the answer, but man, can they really put it in context and they know exactly what this problem is talking about. Okay, E. Using the equation you wrote in part B, determine how many gallons of gas would be needed to travel 756 miles. Okay, so in this one we didn't know the gallons. In this one we don't know the we didn't know the miles. In this one we don't know the gallons. So 756 miles, 28 miles for every gallon of gas. Okay. Here we were multiplying. Here we're actually going to be dividing because 28 and the gallons are being multiplied and we want to isolate our variable. So we're going to do the inverse operation. The opposite of multiplication is division. What I do on one side of my equal sign, I'm going to do the exact same thing on my other side. And I'm going to go off to the side and do that now. Oh, golly. Okay. 28 plus 28 would be 40, 56. 8 plus 6 is 14. 5, 6, 7, 84. Okay, nope, that's going to be 2 times. That's going to be 9. 18. 196. Okay, 84 plus that's going to be 2. 12. Alrighty. Keep going. 140. 168. 180. 109. Oh, look at that. 1, 2, 3, 4, 5. Oh, you can't see that. Sorry. 1, 2, 3, 4, 5, 6, 7. That gives me 196. There's no remainder. Okay, so 27. Right number. If you just write 27, I'm not giving you the credit for that. You're missing your units, which is the bare minimum that I will accept. Okay, it asked me how many gallons. Okay, so 27 gallons. I will accept that and give you full credit. This would be worth 1 point. Still worth 1 point, but really making me confident in your work is if we drove 756 miles, we would need 27 gallons of gas. Still only worth 1 point, but if I was questioning, because I didn't see any work here, like, this is the better answer. And that's all we have. Nope, that's not true. Okay. Vincent shares an idea at his school's student council to install a basketball court for students to use. His scale blueprint is a half-court design that's shown below. Here it is. 1 inch is 15 feet. Student council says the basketball court can be built if it fits in an empty piece of land that measures 25 by 75 feet. Will this piece of land be big enough for Vincent's court to be used? Okay, first of all, if I have something that is 25 by 75, okay, this one here is going to be 2 inches is actually, no, 1 inch is actually 15 feet. So we're going to multiply it times 15 times 15. 25 times 15 is 30. We'd be talking about feet to be the real scale. Okay, here's what I actually do. I'm going to say 1 times 15 is 15. And then 2/3 times 15. Well, divide by 3 is 1. Divide by 3 is 5. 2 times 5 is 10. 1 times 1 is 1. That's going to be 10. And then I'm going to add them back together. So this is 25 feet. I'm assuming from the context of this thing that this is actually just meant to be a half court. We're not doubling it. It's going to stay a half court. Okay, so that means that these are my dimensions. 25, yes. 30, no. But it doesn't say which way it has to go, so we could rotate it and say that we're going to use the full 25 feet here and only 30 of them here. Okay, yep, it fits. So not getting credit. You did all this beautiful work up here to figure it out. Don't just write yes, because I would not give that a point. You need to explain why. It says so in the directions. Even if it doesn't, best practice is to explain. Okay, yes, it fits. Because the dimensions of the half court are 30 feet by 25 feet, which will fit inside the 25 feet by 75 feet empty piece of land. If you want to be real impressive, you could say, though it only fits one way. Because, right, if we did the 30 feet this way, yes, 25 feet would fit here, but 30 feet, no, it wouldn't fit there. You do not need to add that, but if you just want to be like, oh, look at me, I can explain all the stuff, then that would be a good answer too. This one would most likely be 2 points. And the thing about this one is yes is a point. Correct justification is a point. And if you somehow like messed up your math up here and you said that this was like 30 feet and 35 feet, so then you came down here and said no because this is too big, we might offer you what's called a check follow-through point, which means not that you got it right, like 100% right, but it means like I'm following your work and I understand that based on what you thought the answers were, you did come to the correct conclusion. So you could possibly pick up 1 point if you said no because your math up here, and you clearly showed your math, told you that like something went wrong and you got different dimensions that didn't fit. So that's why the justification is so important, because if you just say yes, great. I don't know how you know that. If you just say no, I'm like, nope, that's wrong. But if you say no because, look, I did the math and the dimensions are 30 by 35, then if I follow your math here, I can be like, okay, well, that was the right conclusion if that's what you thought the answers were. So I can tell you understood this part of the question. So I might award you a check follow-through point that's basically saying you got this answer right based on the wrong answer up here. So you're not getting full credit, but you at least get part of it. So always be super detailed in your justification and your explanation so that we can possibly award you those points. Okay, this one is the last one. Ms. Jones invited her class of 25 students to attend a bid trip. Of the 25 that were invited, 18 actually went. They attended. What percent of students did not attend the bid trip? Okay, so I like to draw myself a little picture here. It's called a part whole graph or something. Okay. Attended. Didn't. Invited. Right? Because if you're invited, you either got one of these two options. You either went or you didn't. So how many were invited? 25. Okay, how many went? 18 attended the bid trip. That means that the rest of the 25 that aren't those 18 didn't go. So I could do 25 minus 18, 15 minus 8, 8, 9, 10, 11, 12, 13, 14, 15. That's 7. 0. Okay, 7 people did not go. For me, that's one way to solve it, is I can now go say 7 out of the 25 people did not go. So percent is out of 100. I see a scale factor of 4. 28% did not go. I'm not done writing my answer because I want to actually include that, but I'm going to show you the other way to solve it, which is to go for the 18. 18 out of 25 people did go. Still the same scale factor, times 4. 18 times 4. 8 times 4 is 32. That's not right. 32. 4, 5, 6, 7. Okay, 72% did go. They attended. That means that if I subtract 100 minus 72, 28% didn't go. So you can solve it either way. 28% of the students invited did not go on the bid trip. Lame. They didn't want to go. I would have gone on the bid trip. Clearly box your answer, circle it, something for us to know where am I looking in all of this to find there's the answer. Okay. 1 week later, Ms. Jones decided to extend the invitation to all the 7th grade students at her Yes Prep campus. Whoa, very nice. There are 108 students who attended. Assuming the ratio of students who were invited to the students who attended stayed the same as up here, how many total students are there in the 7th grade? Okay. Good thing I kind of did both of these to show you, because now we can just go back. 28% didn't go. 72% did go. So 72% out of 100 will go. We know that 108 of the 7th graders did go. We don't know how many that is. Okay, so now I'm going to look for a scale factor. Can I get from 72 to 100 easily? No. How about from 72 to... nope. What do I do now? I'm going to look at this one, and I'm going to simplify right here. 0, 2, I can divide them both by 2. 72 divided by 2, 100 divided by 2, it's going to give me 50. 72, 2, 4, 6, 3 times. 12, 6, 36, 50. I still don't really see an easy scale factor. Maybe I'm just not thinking of it. I have a number I kind of have in mind, but I'm not sure. It can't hurt me to simplify it more. Because 6 and 0, both divisible by 2. Divide by 2, divide by 2. That's 25. 36 divided by 2. 1, 16, 8, 18 to 108. Do I know that? Maybe, maybe not. 18 and 25, do they have 5? Times 5 is 25. 1 times 25 is 25. 1 times 18. 2 times 9. 3 times 6. They're not anything else I can simplify them by. So now I'm going to look for a relationship over here. Do I know 18 to 108? Let's say I don't. How do I find it? I'm going to divide 108 divided by 18. That will give me a scale factor that I can use here if I just can't recognize a relationship between any of those numbers. So let's see, 18 goes into 10 0 times, it goes into 1 0 times, goes into 108. Oh, okay, 18. 18 times 2, or 18 plus 18, 8 and 8 is 16, it's 36. 8 plus 6 is 14, 40, 54. 8. Another thing I could do is I could say this is 1, 2, 3. We're going to have 4 times 5 times 6, but I'm looking at this one and I think I can see a relationship there. That if this is times 1, times 2, times 3, times 4, times 5, times 6, I think I can double this. 3 times 2 is 6. 54. Ha, 108. Okay, I could have filled out the rest of them, but I want to save myself some time. When I see a relationship, I'm going to go for it. Okay, whoops. I want to get rid of that. Okay, so that was 6 times, and it's going to go in evenly. Oh, there's my scale factor. Okay, so 18 times 6 will be 108. So now we're doing 25 times 6, and I've got all this empty white space over here, so I'm going to move it on over. 25 times 6. I could do it like this, or I could reason through. I know that 25 times 4 is 100. And 25 times 2 is 50. So 25 times 6 must be 150. Okay. Don't just leave it like that. That has no context. What was the question even? Let's go back. The question is usually in the last sentence. Assuming the ratio of students were invited to the... How many total students are in the 7th grade? In the 7th grade... there are 150 total students. Ta-da! There's your answer. Worth 1 point. So is this one up here. Another way you could have solved it, if this really just wasn't working for you because I was not seeing that relationship, you could have done it the other way. If you know... Oh no, never mind. I was wrong. You couldn't. There you go. Final answer.